Explain how you know when events are dependent. You can use your own words, but when the first event affects the outcome of the second event. Right? Something like that. Example, you draw a marble or a card and do not replace it. Right? Then it will alter the outcome of the second event. That's how you know for sure. Independent, you replace things. Or the first event doesn't affect my second. Classic is a die, right? Whether I roll a 5 here or a 3, it will not affect. If I now ask you, hey, what's the probability of rolling a 4? This outcome doesn't affect the second at all, or the third, or the fourth. Nothing changes here. Same with a coin, right? Gurpreet draws cards from a standard deck of 52 cards. He draws a queen of diamond and does not replace it, okay? He draws a second card, determine. So we're always resetting, right? So if you answer A, answer it and reset, go back to the question, then answer B. So the probability, very important, of the second card being a 5. So we would say for sure that 51 should be in the denominator. How many 5s are there? There are 4 5s. If that's not confusing enough, I made it even more confusing, right? 451 is the answer. So this is, I'm looking at the 51 in particular, okay? The probability of the second card being a queen. So you know you're down to 51. The first event affected the number of queens, right? So there are 3, except for at home, I only have 1 queen, all right? That's my wife. But anyways, here we have 3 queens. Oh, right? Anyways, 3 out of 51. The probability of the second card being a face card. You're down to 51 again. And by the way, the Queen of Diamonds is a face card. So you're down to 11. Sorry, almost wanted to say 12. 11. So can we go back to B? You get 1 for each. 1 for each correct answer. Same for this one because both are affected. 1 for each. The probability of the second card not being a queen. So you can kind of go off of B if you wanted to. But I will just say this. We're still at a 51, right? And we go 51 minus 3 queens. Right? So this would be 48 over 51. So 1 mark for each. One mark for each. Okay. 3. Anthony rolled a 12-sided die 30 times. It landed on 7 in 11 occasions. I don't know, you had to read this carefully. State the experimental probability of rolling a 7. Experimental probability is based on what actually happened. And so it landed on 7 in 11 occasions out of the 30 rolls, right? So you base your answer, right? 30 rolls, okay? Landed on 7 11 times. So it's 11 over 30. I'd say it's all or nothing there. State the theoretical probability of rolling a 7. There's only 1 7 out of, in this case, it's a 12-sided die. So it's 1 over 12. Okay. 1 mark. Next, Anthony rolled the die 1,500 times. How many times would you have expected to land on 7? You have to use the theoretical probability here. So if you pick that one, you get 1 mark. And your answer here is also going to get you a mark. So you get exactly 125 times. So a mark for that, a mark for theoretical. If you grab the 11 over 30 minus 1, but I still give you a mark for multiplying it through. Okay? And remember, if I asked you why are the answers different, is because of the low sample size. 30 is not, you would just say more needs more, he has to roll it more often or increase the sample. Emma has a jar containing 4 blue, 5 red, 7 green candies. What is that? 5 and 4 is 9, and 7 is 16 candies. Okay. She picks a random candy and gets a blue one. She replaces it, picks another one. We're talking independent events. Independent probability. Okay. State the probability of the second candy being red. By the way, nothing changes, so we have 5 reds over 16. That's it. State the probability of the second candy being a blue one. We've got 4 blue, and we still have 16 total. So here, it's almost like, why did you even tell me what happened before? To test your knowledge, right? There's a replacement, so nothing changes. It stays 16. So what are we at here? I think we're 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. Yes. So we're out of 14. If you need to see this yet and add it all up, you can do so.